Now that we've been working with these trig functions, we want to start graphing them. We've talked before about if you plot enough points, you can graph anything on the face of the earth. And so that's the case here in section 4.5. We want to start with the graph of the sine curve. Now, if I take the values off of the unit circle that we've been working with 0, pi over 6, pi over 4, pi over 3, pi over 2. That's the first quadrant, right? So if I'm just using those values off of the unit circle that we have memorized, I could go through and say, okay, I know the sign at 0 is 0. So let me plot that ordered pair right here, 0, 0. I know the sign at pi over 6 is 1/2. So let me plot that ordered pair right here. Now, you'll notice that on the grid, they jump from 0 to pi over 2. Halfway in between 0 and pi over 2, because pi over 2 is 90 degrees, right? Halfway in between 0 and pi over 2 would be pi over 4, 45 degrees. And a little bit in front of that would be pi over 6, 30 degrees. And a little bit past that would be pi over 3, 60 degrees. So we could kind of lay that out for ourselves. So over here at pi over 6, we've got 1/2. Right? Then we could do pi over 4, and when we put that in, we get square root of 2 over 2. Decimal equivalent of that is 0.71. So I could plot 0.71 with the pi over 4. Then pi over 3, we get square root of 3 over 2. That's 0.866, so 0.87. So we could plot that one. And then pi over 2, we get 1. And we could keep going all the way around the unit circle with all of those values that we have memorized. And we would create the smooth curve that you see here. Here's the curve that we get from the first quadrant. And if we kept going the rest of the way around, here's our second quadrant, here's our third quadrant, and here's our fourth quadrant, just by plotting those values. Now, a couple of things about that sine curve. Just like we can find an infinite number of coterminals, that curve is going to go on and on and on. It's going to repeat without end. And you'll also notice that it follows a pattern. It keeps doing the same thing over and over and over again. That's called its period. Just like during the course of the day, you go through 6 or 7 different periods, follows a pattern where you have a class and a break and a class and a break. Same type thing. This has a period of 2 pi because if you put your finger anywhere on this graph that you want to, like if I put my finger right here at 0, and then I put my finger where it starts doing that same thing again, notice the difference between them is 2 pi. If I came here and said, okay, I'm going to start right here, where it does that same thing again is over here at 3 pi, the difference between 1 pi and 3 pi is 2 pi. If I started right here, where it does that same thing again is right here, the difference between those 2 points is 2 pi. So it has a period of 2 pi, and that's why we get to find coterminals by just adding or subtracting 2 pi, because this thing does the same thing over and over again. It repeats itself every 2 pi. And it's going to extend infinitely in both directions. We could go through the exact same discussion with the cosine curve. If we went through and we made a table of values of everything off of the unit circle that are the values that we know already, we could create the graph that you see there on the bottom of the screen. Now, if we start thinking about, when I do homework, I do like 15 of these. You're kidding. I'm going to have to make a table of values with like 20 values in it, 20 different times. I'm going to be here all day. We need a more practical way of doing this. And so if you notice, if I pick the extreme highs and lows, I can get a pretty good idea of what this graph looks like. For instance, if I plotted just 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0, just those 5 points, that would give me how high up to go and how low down to go and where to cross the x-axis. I mean, that'd pretty much be everything I need. And so we're going to stick to those 5 key values when I'm graphing. So for the first one, when they say graph y is equal to sine x, instead of making a table that's got 20 different values in it, here's those same values that we were just talking about. 0, pi over 2 pi, 3 pi over 2, and 2 pi. Those are those boundary markers in between the quadrants. The nice thing about those values is they're really easy to remember, because if you think about it, that's just where, like if I start at the center and I go over 1 to the right, I'm at 1, 0. I go up 1, I'm at 0, 1. I go back 1, I'm at negative 1, 0. I go down 1, I'm at 0, negative 1. And that, again, is on a unit circle where sine is the same thing as y and cosine is the same thing as x. So that means it's going to be really easy to figure out those values. There's none of this, okay, sine of pi over 6, is that square root of 3 over 2 or 1/2? I got to draw the whole first quadrant thing. None of that, okay? So if I go through and I say, okay, I'm going to take 0 and I'm going to put it in the place of x right here, then I'm saying, what's the sign at 0? And so I can come over here and say, at 0, the sign is my y value, so it would just be 0. Then I want to look at pi over 2. So if I'm looking for the sign of pi over 2, that means I'm going to come up here to pi over 2 and say, what's my sign? What's my y value? Well, it's 1. So I could plot that. At pi over 2, I'm going to plot 1. Alright, then I'm going to plug in pi. So that would be the sign at pi. So I can come over here at pi, the y value is 0. So let's plot pi 0. Plug in 3 pi over 2, so that would be sine of 3 pi over 2. So right down here, my sine value is -1. So let's plot 3 pi over 2, -1. And then 2 pi, that would be the sine at 2 pi, which is back over here again, so that would be a value of 0. So we could plot 2 pi 0. Now, as long as I remember to connect this with a smooth curve, I don't want to make like straight lines and kind of make it look like a zigzag. I need to remember that this is a curve. As long as I know what that basic shape looks like, then I can connect this with smooth curves and make it look normal. All right, let's try the cosine curve doing that same thing. All right, for the cosine curve, we've got y is equal to cosine x. So we can start by plugging in 0. Oh, one thing I wanted to mention to you, remember we said this goes infinitely in both directions. So once I know what that first curve looks like, then I could keep extending it in both directions, both positively and negatively if I wanted to. Okay, so for our cosine curve, if we plug in 0, we can say, okay, what's the cosine at 0? So come over here, and our cosine is our x value. It's 1. So we can come up here and plot the point 0, 1. All right, then we'll take pi over 2 and plug it in. So that would be the cosine at pi over 2. So right here, cosine value would be 0. So we can plot pi over 2, 0 right there. All right, then plug in pi. So cosine at pi right here would be -1. So let's plot pi -1. So right here at pi down to -1. If we plug in 3 pi over 2, cosine at 3 pi over 2 is just going to be down here, so it's going to be 0. So at 3 pi over 2, we'll plot 0. And then 2 pi 1. All right, so again, we know that we're going to connect those with a smooth curve. And so when I connect those, there's my graph. And again, once I know what one of those looks like, then I can extend it infinitely in both directions. Now, if you notice, the sine and the cosine curve look remarkably alike. Like they're literally just, if I took my sine curve and I backed it up pi over 2, I'd get the cosine curve. If I take my cosine curve and I shift it forward pi over 2, I get my sine curve. That goes back to the idea of cofunctions of complementary angles are equal to each other. Remember, we would go through and say the cosine of pi over 2 minus theta is equal to the sine of theta. Exact same idea. Now, there are lots of things about the sine and the cosine curve that we can change. Like before, we've done horizontal and vertical shifts and those type of things. We're going to be able to do those things to our trig functions as well. So if you'll notice right here, here is the general equation that we're going to use for a trig function, and we'll notice some of the things that we can change. This is not new to us. Any value subtracted from x is still a horizontal shift, and any value subtracted from y is still a vertical shift. So if it's over here, we could subtract it to the other side, and we would have y minus d. So we can see how that would be a vertical shift. But the two things that are new to us here are amplitude and period change. So we're going to start talking about amplitude. Amplitude is just how high and how low something goes. Like think about music, an amplitude of music. How high and how low something goes. So your amplitude can be found by doing your highest value minus your lowest value divided by 2. Maximum minus minimum divided by 2. If the number out in front of your function, your a value, is larger than 1, it's going to cause a vertical stretch. And we've talked about that before. Remember Charlie Brown and the silly putty and stretching him vertically and making him a cone head, right? If A is a number between 0 and 1, it's going to cause a vertical shrink. So that's where we took Charlie Brown and we smushed him together and made him like a squatty body. Same idea. So over here, if I've got y is equal to 2 sine x, I literally could go through and take those same 5 values that we were working with before and just plug them into the equation and get ordered pairs and plot them. I could do that. But I'm going to end up doing this so many times. It'd be nice if I could figure out how to change the amplitude without actually having to plot the points. If you think about it, when this says y is equal to 2 sine x, that 2 in front of sine means that now the amplitude is 2. It's going to go twice as high and twice as low. It's like every one of my y values got doubled, right? So if you think about that, if I took the normal sine curve and I made it go twice as high and twice as low, instead of going up to 1 and negative 1, it would go up to 2 and down to negative 2, right? So we could probably kind of ballpark draw that without needing the points. But for this first one, let's plot the points and see if it gives us what we think it will, okay? So we can go through and say, all right, let's put in 0. Oh, hang on, let me back up one thing. I wanted to mention to you that you can graph all of these trig functions on your graphing calculator as well. If you do that, you're going to need to be in radian mode, and there's a zoom setting that's really helpful. Grab your graphing calculator a second. I need to make sure I'm in radian mode. We've been toggling back and forth between degrees and radian, so I'm not really sure what you might be in from whatever the last problem was you did. You'd want to be sure that you were in radian mode. And when you go to y equals, you can type in sine x. Now, you can graph that on any zoom that you want to, but there's a zoom specifically set for trigonometry that's really cool, and it's zoom number 7, zoom trig. So if you go to zoom, and instead of choosing like the zoom standard or the zoom square, one of those typical ones that we choose, if you choose zoom trig, here's what it does. It literally graphs 2 perfect cycles of that trig function. It goes from negative 2 pi to positive 2 pi, counting by pi over 2. So just a second ago when we were drawing this on our paper, we were going 0, pi over 2 pi, 3 pi over 2, 2 pi. Your calculator does that exact same thing, and it gives you one complete cycle on the positive side and one complete cycle on the negative side. So like if I hit window, you can see basically that's what it's doing. It's a little bit shy of 2 pi, but you can see it gives you a really good picture. So we use zoom trig a lot when we're graphing these. And we could do the same thing with that cosine curve, and it would give us what we had gotten over here on the positive side, and then it also gives us an additional one over here on the negative side. So just wanted to mention that to you, that you can graph these on your calculator.
Katie Hadwin, if you are in the building, please report to Ms. Sasser's office. Katie Hadwin, thank you.
Okay, so if we go back to y is equal to 2 sine x, and we start by putting in 0, all right? If I put 0 in the place of x, sine at 0, remember, is 0. So if you double 0, you're still at 0. So I'm going to have 0, 0. Then if I put pi over 2 in the place of x, sine at pi over 2 was 1. So if I double that, I'm going to get 2. So I can come up here and plot pi over 2, 2. If I plug in pi, sine at pi is 0, double that, I still have 0. Plug in 3 pi over 2, sine is negative 1, double that, I still have negative 2. And then 2 pi, sine there is 0, double that, and I still have 0. So if I connect those dots, sure enough, I have exactly what I thought I was going to. I have that sine curve that's going twice as high and twice as low. And again, if we go back to that formula for amplitude, maximum minus minimum divided by 2, my maximum is 2, my minimum is negative 2, so 2 minus a negative 2 would be 2 plus 2. So 4 divided by 2 would give me that amplitude of 2. I need to be careful that I don't just look at a graph and look at how high it's going up and assume that's its amplitude, because this function could start at 0 and go up to 2 and only come back down to 0, like not go all the way back down to negative 2. We can take these functions and vertically shift them, right? So you could take the normal sine curve and bump it up 1 unit, and it would be going up to 2, but it wouldn't be going down to negative 2. It would only be going down to 0. So amplitude, using that maximum minus minimum divided by 2 will keep me from making a mistake of just looking at the highest value and assuming that's my amplitude. All right, so look at the next one. For example 2, we've got y is equal to cosine x, and you can see they've got a number 1/2 out in front of the function, so they've changed the amplitude. What do you think that 1/2 is going to do? Here's our normal cosine curve. I just threw it on here for you. What do you think that 1/2 is going to do? What will it do to our graph?
Decrease it.
It'll decrease it, it'll shrink it, so it'll go what? How high will it go? Yeah, it'll go half as high and half as low. So it'll go up to 1/2, it'll go down to negative 1/2. I'm not changing it at all vertically. It's still going to have the exact same x-intercepts. So try to just sketch that one. It's in pencil. You can erase it and change it if you need to. Try to just sketch that one, what you think it would look like, drawing the cosine curve with an amplitude of 1/2 before we do it together. You are always welcome to plot 5 points, but it's going to get really old really fast if I'm having to plot a bunch of points every single time I graph these. I want to get to the point that I can graph just by changing the amplitude without having to plot points. Okay, so if you did go through and plot points, you'd get 0, 1/2, pi over 2, 0, pi negative 1/2, 3 pi over 2, 0, and 2 pi 1/2. So if you graphed it exactly what you told me, you would get the exact same curve, but only going up to 1/2 and down to negative 1/2, going half as high and half as low. So again, try to get to the point that you can graph that without needing to plot points. All right, look at the next one. For the next one, they asked me to graph y is equal to 3 cosine x, and then also y is equal to negative 3 cosine x. Well, let's start with y equals 3 cosine x first. All right, what is that 3 out in front going to do? What?
Stretch it.
It's going to stretch it, right? So it's going to change its amplitude. How high will it go? 3. It's 3 times as high, right? So it'll go up to 3 and down to negative 3. So try and sketch that without plotting points. Draw your regular cosine curve, but have it go up to 3 and down to negative 3. All right, so here's our normal cosine curve, in case you need a pattern to go by. All right, and this is what it looks like if I go up to 3 and I go down to negative 3. Instead of being at 1, I'm at 3. I'm still at 0 when I triple it. Instead of being at negative 1, I'm at negative 3. Still at 0 when I triple it. Instead of being at 1, I'm at 3. So that green graph would be 3 cosine x. Now here's a blast from the past. What do you do to a graph when you throw a negative out in front of the whole thing? What does that cause? A reflection, right. It causes a reflection in the x-axis. So they expect me to remember all that stuff that they've already taught me. So if I take that green graph that I have, and that negative out in front causes a reflection in the x-axis, then I'm just going to reflect it across the x-axis, and that will give me the red graph. Again, you are more than welcome to plot 5 points for that red graph. But it's a whole lot easier if we can get to the point that we can shift and reflect and change amplitude without having to do that. All right, what we're going to focus on tomorrow on the second half of this lesson is how to graph when our period gets changed. Remember we said that if there's a number in between cosine and x, it's going to change the period. And what it's going to do is my new period will be my original period divided by my b value. So for instance, when we've got y is equal to cosine 2x, then I'm going to take 2 pi, and I'm going to divide that by my b value of 2, and that'll give me a period of 1 pi. So my original period for cosine is 2 pi. My b value is 2, so 2 pi divided by 2 means my new period will be 1 pi, and we'll see how that will affect our graph tomorrow. Look at another one of those. If I look at this one, I've got cosine x over 2. It might actually be easier to see it if I rewrite that cosine 1/2 x, so then it's easier to see that the 1/2 is in between cosine and x. So to come up with my new period, I'm going to take my original period for cosine, which is 2 pi, and I'm going to divide that by the b value, which is 1/2. So 2 pi divided by 1/2 is going to give me 4 pi. Now, one other thing up here about amplitude that I just want to point out to you amplitude is always a positive value. So when you're looking at y is equal to negative 3 cosine x, if they ask you what's the amplitude of that, it's going to be positive 3, because I'm still saying my maximum 3 minus my minimum negative 3 divided by 2, that's still going to give me a positive 3. Amplitude is always positive.